Hello, we're in section 4.4 now, and we're going to once again talk about maximizing now profit and revenue. So actually more applications of derivatives. All right, so for example, the revenue for selling Q items is given by this function. Looking at that, it looks like we could say then it's 1254 times Q. So Q is the number of items. So we're saying that we're selling the items for $1,254 per item. Okay, that's how we calculate revenue. Price times quantity. The cost for producing Q items is given by this function. So we have a quadratic cost function, which we don't always see that. How many items which basically means we need to find Q, should we make and sell to maximize profit? Okay, so we need to come up with a function that will calculate the profit, and then we can find the value of Q that makes it a maximum using the derivative and finding a critical point, etc. Okay, so profit function. Remember we use pi for profit. And what do we remember? We remember that profit is revenue minus cost. All right, and we use the letter pi, or the symbol pi, I should say, to count for profit. So our profit is going to be in terms of quantity sold, number of items. All right, so it is the revenue function in terms of Q minus the cost function in terms of Q. We've done this plenty of times. Okay, so it's 1254 Q Now you got to be careful. We have to put that in parentheses because we are subtracting. So distribute, and we end up with, if we distribute and combine like terms, we end up with a profit function, negative 11Q squared plus 1254Q minus 5,000. Okay, so here's how we can calculate the profit based on the number of items produced and sold. Okay, so we're looking to find the maximum quantity, or the quantity that will produce maximum profit, which means we need the derivative. So the derivative of the profit function would be negative 22Q plus 1254. All right, and of course, then we want to know what, find the critical point, set it equal to 0, and solve. I don't know why that does that. So if we solve this for Q, we get Q equals 57. Okay, now, one thing we have to think about here is, do we have an interval? Are there any restrictions on Q, which we as in me, should have actually gone back up and thought about this. Any restrictions on Q? Well, Q can't be positive, so it has to be greater than or equal to 0, but Q, the quantity produced, can get bigger and bigger and bigger, so there is no upper limit. So here we would say that Q has to be greater than or equal to 0. So technically we're trying to find the maximum value on this interval, which happens to be from 0 to infinity. Okay, so to prove that 57 does produce our maximum, we would do the first derivative test. And this is 0. So we would choose a value in each of those intervals. So if I choose 20 here and 80 here, and we substitute them into the first derivative, remember if it changes sign at 57, then that critical point is a max or min. All right. So if I plug 20 into the derivative, which would be over here, if I plug 20 in here, I'm going to get a positive number. And if I plug 80 into here, I get a negative. So I know that my profit function is increasing on the interval from 0 to 57 and decreasing from 57 to infinity. So that tells me that at 57, I have a local maximum. Since we're not talking about a closed interval, and we know this is the only local extrema, then it has to also be a global extrema. So it is also a global maximum. All right, so the question is saying how many items should we make and sell to maximize profit? So if we summarize that, we say, okay, we should make 57 items to get a maximum profit of, when I plug in 57 into the profit function, I should get $30,739. Okay, so let's look at another example of maximizing profit. Now we're talking about demand for a quantity Q of a product at a price given by this equation. So basically we're saying if we know the quantity demanded, we can calculate the selling price. Fixed costs are $8,000 and you're going to sell it at, or it costs $24 per item to make. All right, how many items? Which means Q, should we make to maximize profit? Okay, so what that's telling me is we need a function that will calculate profit in terms of Q quantity. Okay, so we need all right, so let's create that. We know that profit is revenue minus cost, so we need a cost function in terms of Q. And if we have $8,000 fixed costs, Then we've got our $8,000 fixed. And then it's $24 per item. So then that would be our variable cost. Okay, there's our cost function. Now we need a revenue function in terms of Q. So remember, revenue is found by taking price times quantity. Right? So we know the selling price is selling prices in terms of Q, and that is 872 minus 8Q, and quantity is Q. So we can come up here, we've got a revenue function based on Q, which is 872Q. Okay, so I've got cost, I've got revenue. I can now create a profit function. Notice both of them are in terms of Q. That's important. All right, so profit in terms of Q, number of items, is revenue minus cost. Once again, don't forget the parentheses because you're subtracting. All right, so distribute and combine like terms. And we come up with a profit function in terms of Q of negative 8Q squared plus 848Q minus 8,000. All right, so that's the function that calculates profit based on number of items. Produced, sold, etc. Okay, so what are the restrictions on Q here, on quantity? All right, so Q we know has to be greater than or equal to 0. Now, is there a maximum quantity that we can sell? Okay, well, let's think about it. What is quantity dependent upon, or what depends upon quantity? Price, right? So we want a quantity that's not going to produce a price of 0 or less. Okay, so if I'm talking about my price, I'll come down here. What's going to make it 0? Because that would be our maximum quantity. Right? We want to make sure we're selling price more than 0. So if we solve this, 8Q equals 872, and Q comes out to be 109. All right, so the quantity produced and sold has to be between 0 and 109. All right, so we're finding the maximum value of a function on a closed interval. So we can, we need the critical point on that in that interval, and then we can test those values. So my derivative of the profit function is negative 16Q plus 848. Set equal to 0 to get the critical point. So Q is equal to 53. Okay, so that's my critical point. So technically we need to check our profit at the end points and the critical point inside that interval, because 53 is between 0 and 109. So if we test those in the profit function, so if I find the profit at a quantity of 0, a profit at a quantity of 53, and profit, at a quantity of 109. All right, and well, this is going to be 0. This is going to be 0. So here we're going to get oh my gosh. All right. So if we 53 items, we produce them and sell them, we'll make a profit of $14,472. All right. So let's check the question again. How many items should we make to maximize profit? What should we charge for the item, and what is the maximum profit? Okay, so we'll summarize now. Okay, we should make 53 items to get a maximum profit of $14,472. Okay, and what should our selling price be? So we've got to come up with that selling price. All right, so we know that the selling price is $872 minus 8 times Q, or 8 times 53, which comes out with a selling price of $448. Okay, so we should sell each item at $448. There you have it.